All right, everyone, welcome back. Let's resume our symposium. So let's welcome our next presenter, Matthew Zink. Matt is a second-year master student in the Quantitative Fisheries Centers, advised by Dr. Travis Burden, with a bachelor's degree in zoology and a certificate in mathematics from University of Wisconsin-Madison. Matt is interested in fishery sustainability and stock assessment methods. Today, Matt is giving us a presentation on Lake Huron Atlantic salmon demographics, dynamics, and angler exploitation and valuations. With this, I will give the floor to Matt.
Alrighty, thank you so much. Excellently advanced my slide there. Before I get started talking about my master's research over the last couple of years, I'm going to give a brief history on some Atlantic salmon in Lake Huron and the Great Lakes, as well as some information about Atlantic salmon. So to get started, Atlantic salmon are an anadromous species, but they're totally capable of completing their life cycle entirely in freshwater. They don't have to migrate out to sea. Unlike some of our other salmon species in the Great Lakes, they're aeroparous. They can spawn multiple times in their life, which is typically 4 to 7 years, where they spend the first 1 to 3 in freshwater before they migrate out. And compared to some of the other salmonids out in Lake Huron, they have a relatively broad or diverse diet. And so for Atlantic salmon in the Great Lakes, they're actually native to Lake Ontario. They were stocked for a short while in the 70s as well to control invasive prey populations. The Lake Ontario population was extirpated from overfishing in the mid-1800s. And despite this history in the Great Lakes, still little is kind of known about this freshwater life cycle of Atlantic salmon. So what's really important from these last two slides is that there already existed a Great Lakes sustained Atlantic salmon population, and that Atlantic salmon have a broader diet than some of the other salmon. Which brings us to the Michigan DNR Atlantic salmon stocking program. The Michigan DNR began stocking Atlantics in 2011, but interest in this species grew after the 2003 alewife collapse in Huron. The Chinook salmon did not respond well after that prey base collapsed. And in search of a more resilient sport fish, Michigan DNR explored Atlantic salmon, thinking that they would be able to find other food in the lake if that pelagic prey population continued to flux. The other component here is LSSU, that's Lake Superior State University. They've been stocking Atlantic salmon in the St. Mary's River for well over a decade now. And then in 2011, the Michigan DNR began their stocking, matching the St. Mary's River stocking location for 2 years. And then in 2013, they opened it up to lake-wide stocking, which is where you'll see a big spike in the stocking numbers. And so the stocking program's been around since 2011. How's it been doing? The Michigan DNR currently uses this 2% return to creel metric to assess the success of their program. As you can see on this plot, what we're looking at is the number of fish harvested in a year compared to the number of fish stocked in that year. So for literally every year except one, they missed this benchmark. But for several reasons, we think this threshold or this metric doesn't adequately describe the Atlantic salmon fishery. And this is kind of what brought my project about. So problems with this 2% metric, Atlantic salmon make their fall run in November, and the Michigan DNR open water boat creel runs from April to October. So it's possible that a good portion of shore harvest is missed during this Atlantic salmon spawning run. And then on top of that, there are 4 or 5 different silvery salmon out in Lake Huron. And so people's ability to ID Atlantics when they catch one, we just don't really trust that they are. And so this could lead to some issues in terms of word of mouth spread of the fishery if people are posting about catching Chinook salmons that are actually Atlantics, for example. And then also this is a consumptive focused metric. So any value for catch and release anglers that this fishery provides would not be captured by this metric. And then finally, this metric doesn't have a chance at accounting for the value associated with the opportunity to fish for Atlantic salmon, which kind of brings us to the project goals and objectives, where overall I wanted to evaluate the success of the Michigan DNR Lake Huron Atlantic salmon stocking program. And for our first objective, we're really kind of doing an evaluation of the Lake Huron salmon fishery to try and answer that question of how valuable is the opportunity to fish for Atlantic salmon in Huron, as well as some of the other species. And then kind of the second prong of our approach to evaluate the success of this program is to look at the Atlantic salmon population demographics and dynamics for things like abundance at age and our mortality rates. So starting with this valuation to collect data for it and perform it, we had to build an email survey. We built the survey in Qualtrics. This is a survey instrument provided by MSU. It took just under a year. It took a long time to develop a robust survey that gathered all the data we needed. And additionally, we underwent cognitive interviews in this testing phase, which basically just made the survey even stronger, but took some extra time. And then finally, our survey was distributed by the Michigan DNR to online license buyers of 2019 that approved or opted to receive emails from the Michigan DNR. And then the kind of backbone of the survey is designed to collect information on 2019 fishing trips targeting Lake Huron salmon. And so within Qualtrics, the survey is kind of broken up into organizational units called blocks. So there's this travel cost block, this preference scenario block I'm going to be talking about. The demographics block would be another example of one. But this travel cost block, here we ask the number of fishing trips taken by anglers and then the kind of the costs associated with those trips. So whether you drove a truck or a Prius, whether you towed a boat, things like that. And this data gets used to build a travel cost model or a travel demand model where we estimate the number of trips as a function of the fishery status and the costs associated with travel. And so that kind of brings me to this preference scenario block to get at the status of the fishery. We asked respondents to say how the number of trips they took in 2019 would change based on changes in the Atlantic or the Lake Huron salmon fishery. So we presented the 5-year average catch rates from the Michigan open water creel data for Atlantics, cohos, Chinooks, lake trout, and steelheads, and then presented a range of different catch rates, and anglers responded how many trips they would take. And in doing so, we can tease out the species anglers prefer without defining the mechanism by which these catch rates change, whether it's a stocking increase of one species or some unforeseen mortality that drives another species down. Now moving on to some other blocks, our harvest block in the survey was actually used in the assessment work. But in this block, we ask where, when, and the mode by which Atlantic salmon are being harvested by boat or by shore, for example. And then the goal of this block is really to identify how much of the true total harvest that the Michigan open water creel covers in time and space, and then identify if there is a catch and release angling component to this fishery. And the last thing I have today from the survey is the salmon ID block, where I put up pictures of silvery salmon and had respondents name the fish. But first I'm going to talk a bit about the population assessment and looking at these demographics and dynamics. For this part of my project, I built a statistical catch at age model to estimate Atlantic salmon abundance and mortality rates for the years 2011 to 2019. I modeled from ages 1 to 7, but I lumped ages 4 to 7 in a 4+ group for harvest due to some age comp data. And then for data sources, we have our data from the Michigan DNR, where we compared the total harvest of Atlantic salmon and then adjusted for by the results of our survey in that harvest block. And then we also looked at the age composition of the harvest. And we had a little issue here because of some age estimate issues within the MDNR creel program. So we actually took their coded wire tag data to get absolute age and absolute length and applied Ogo's method to get an age length key to re-age our sample from the MDNR to feed into our model. Stocking numbers were then, again, just recorded from the MDNR and LSSU, and throughout it, natural mortality was assumed to be 0.2. The other aspect to this what really goes on in catch at age modeling is this population submodel is this first part where we have initial abundances and recruitments to forecast abundance at age. And then we also have natural mortality and fishing mortality. And so normally in a catch at age model, this initial abundance and recruitment are parameters that get estimated, but for my case, they are not. There's no documented Atlantic salmon recruitment going on, so we don't estimate it. We treat it as known as the stocking values. And then for the initial abundance, this is a new program, so there haven't been that many Atlantic salmon in this huge system for a while. So we simply forecasted and fixed these initial abundances from previous LSSU stocking classes. So now from this population submodel, we can compute the observational quantities that we're interested in, like the total harvest and the age composition of the harvest that actually gets used in fitting the model. And so now the second part of our population assessment, we looked at the condition of Atlantic salmon. I used the Michigan DNR open water creel biodata and fit linearized log transformed length weight data using GLMM, TMB, and R with the goal of identifying any yearly variation in condition by predicting weights of Atlantic salmon for given lengths and given years. These were hierarchical growth models. I fit the base model as a fixed effect model with a single slope and single intercept, and then had yearly varying slopes, yearly varying intercepts, and then a final model with yearly varying slopes and intercepts. And anything that varied by year was modeled as a random effect. So then stepping into some of my general survey results, the first 10% of the survey went out on 9/24, and then the remaining 90% went out on 9/28. This is just a standard test release, full release pattern. And then we sent out 2 reminders, one on 10/6, one on 10/13, and then the survey closed a week after that. We sent out a total of 211,000 emails or so, and got over just over 3,500 responses. Our response rate was quite low at 1.7%, and the completion rate was 59%, but we still got well over 1,000 responses, which we were happy with because we asked for a very specific subset of anglers from the survey list, which is Lake Huron salmon anglers. The trail cost data and preference scenarios are still being analyzed and modeled, but I do have the harvest block results for today. And so what this table will show is the percentage of the open water, or percentage of harvest that the open water creel does cover. That is this top left box right here, this 42%. So the creel runs from April to October in this spatial component. The Lake Huron tributary and the St. Mary's River are examples of 2 spatial components outside of the operation of the open water creel. And then this November to December is kind of describing that fall run period. So as you can see from our survey results, only 42% of all Atlantic salmon harvest occurred within the temporal and spatial boundaries of the Michigan open water creel. And the next biggest contributor was the St. Mary's River. And then for salmon ID, this is just the results for Atlantic salmon. People also had to ID Chinook, cohos, and steelheads. But for Atlantics, there were 3 of them that were potentially seen, and 24% of the time they were ID'd correctly. 14% of the time they were mistaken for Chinook. And then the next biggest group was cannot tell from picture, they were unsure at 15%. So overall, Atlantic salmon ID did not go great, and there is definitely some room for improvement there. I'm finally gonna move on to some results from this catch at age model and the assessment. This is the observed versus predicted total harvest of Atlantic salmon over the years in numbers of fish. As you can see, they overlap pretty much perfectly. And in fact, the confidence intervals are so small, they can't be seen on this scale. This isn't totally uncommon for a catch at age model, but is likely partially due to the fact that I didn't have to estimate recruitment or initial abundances, allowing for this really tight fit. Our other analysis of fit was looking at the observed proportion of age of harvest versus the predicted proportionate age of harvest. And this is analyzed using this mean age of harvest. And our model here across the years 2011 to 2019 over predicted this gray line and triangles, this mean age of harvest. This just indicates that there's something going on with the model that needs more investigation. And the last thing I have from the catch at age model is actually the Atlantic salmon population abundances through the years. So this abundance is just a number of fish. Again, the confidence interval, 95% confidence interval here is just a couple hundred fish. So that's why there's a black line that's going through each point. Again, lake-wide stocking, started in 2013. And then we obviously see a sharp growth in the Atlantic salmon population. And then this population appears to have settled kind of around 600,000 fish. And then finally, the last thing I have, the quick side note. If you took that survey or that 2% return to creel metric and adjusted it for our survey harvest ratio, the DNR actually meets their benchmark in 4 more years and still doesn't account for the catch and release fishery or the value of the opportunity to fish for Atlantic salmon. And now finally, we have the expected weight at length for the given years for Atlantic salmon. The best model was selected by AIC. The model that estimated yearly slopes and yearly intercepts wasn't able to fit. And the best model estimated a single intercept and yearly slopes. And again, those slopes were varying yearly. So what we have here is the expected weight at length for a 50 centimeter Atlantic salmon, which is about the 25th percentile. The 60 centimeter Atlantics, which are about the 50th percentile, 68 is the 75th, and then 75 is somewhere in the 80 to 90th percentile, just looking at our bigger salmon in the lake. And throughout the years, you can see that Atlantic salmon condition varies a little bit, but not much overall, indicating that Atlantic salmon have been finding the food they need throughout 2011 to 2019. And so our conclusions this far, if the Michigan DNR is to solely rely on the open water boat creel program for quantifying Atlantic salmon harvest in Lake Huron, they're probably going to underestimate that true harvest by quite a bit. And then at their current stocking levels, that Atlantic salmon population is right around 600,000 fish. And then most notably, the Atlantic salmon condition has been relatively stable, even though overall abundance has been increasing. So we haven't seen any density dependent effects on Atlantic salmon condition yet, indicating that despite their population growth, they're doing quite well out in the lake. So with that, I would like to say thank you to the Blue Water Sport Fishing Association, who helped fund this project, as well as the Michigan DNR, LSSU, and then my advisors, my committee, and everyone who tested my survey. And I would love to take any questions.
All right, great. Thanks, Matt, for this interesting presentation. And we do have time for probably 2 questions. Any question from the audience? Oh, we got one from the chat box. The question from Emily, were there any survey results you threw out as outliers or found unrealistic?
Yes, so this was an incredibly large survey. Some people in every survey just take the opportunity to say whatever they want. So there were some ridiculous responses that were out there, but not really that would have been too impactful on, like, say, this harvest block or the trip block. For the most part, those went well. I would say that there were only a few here and there where people just wrote something that was nonsensical.
Any other questions? Last minute burden question. I don't see any. Then let's thank Matt again for this presentation. Good job, Matt. So next, we will have next presenter. We will take a break from fish, and actually we will have a presentation about rattlesnake for this afternoon. Our next presenter will be Jillian Sturman. Jillian is a first-year master student with Dr. Gary Roloff and Dr. Rick Kemba. So Jillian's interested in anthropogenic effects on federal listed species and developing and updating management strategies to mitigate negative human impact. She primarily has worked in wetland and forest systems with a bachelor's degree in biology, ecology, and evolution from DePaul University in Chicago. Today, Gideon is giving us a presentation on Eastern Massasauga rattlesnake root ecology.